Are you ready, kids? I can hear you. Oh, who does math in silly hats and is an OG? Welcome to another episode of Math in Silly Hats. Today we're going to be going over a topic that's very similar to the last one in our series. This one is evaluating equivalent expressions. We're going to have to use algebra and the order of operations to do so. Let's get into it. All right, guys, here we are in ALEKS, and I'm going to go through two example problems with you. I'm going to be using whiteboard.fi to show my work. So my first problem, I've been given an expression that's already simplified, and I have to compare it to some expressions that aren't so simplified. So let me go write this in Whiteboard. I'm going to use my equation editor. My first expression was 6x plus 54. This is already simplified, so I just need to compare it to any expressions that I was given. The first expression I was asked to compare this to was 6 times x plus 6 times 9. Go ahead and insert that. Now this can be simplified, and I need to simplify it to be able to compare it. So you'll notice that 6 times x, when we multiply a constant by a variable, we just get a coefficient in front of that variable, 6x. And then 6 times 9, nice, is 54. Well, that worked out nicely. 6x plus 54 is the same as 6x plus 54. Let's get that a check mark. Nice. The next expression we were given was 6 times the sum of x plus 9. Now here, we try to go through the steps of PEMDAS, the order of operations. We have parentheses, exponents, multiplication, division, addition, subtraction. The problem here is we try to work inside these parentheses, and x and 9 are not like terms, so we cannot add x and 9. We don't have any exponents, so we go straight to multiplication. Now this is a special type of multiplication because 6 is multiplying everything inside these parentheses. Now this is what's called the distributive property, and that means when we have something trying to multiply everything inside a parentheses, what's multiplying it will multiply each term inside the parentheses. So this would be the same as 6 times x plus 6 times 9. See how that works? The 6 multiplies the x, the 6 multiplies the 9. Now we can simplify that just as before. 6 times x is 6x, 6 times 9, nice, is 54. And again, we have 6x plus 54. Nice. So we know our first two expressions are equivalent to our original expression. Our next expression was 6 times 9x plus 1. Again, we're going to have to distribute. 6 multiplies 9x, then 6 multiplies 1. So 6 multiplies 9x, and 6 multiplies 1. We can simplify. 6 times 9x is 54x. 6 times 1 is just plain old 6. I see what you did there. I've got a 54, I've got a 6, but x is hanging with the wrong crowd. I see you, x, and let's do what we did yesterday. Let's color code. My variables are green. My variables are green. My constants are blue. My constants are blue. So you see what they've done is they've put x with the wrong crowd. In other words, they put the x with the 54 instead of with the 6. 54x is obviously not the same as 6x, and 54 is not the same as 6. So these are not equivalent. All right, our last expression is a simple one. It's just 60x. Well, these are not like terms, so they can't combine. And even though 54x plus 6x would be 60x, 54 and 6x are unlike terms. They cannot combine. So this is obviously not the correct expression. So our first two expressions were equivalent. Our last two were not. Let's come back over to ALEKS and let's do our second set of comparing expressions. Here we have an expression that isn't simplified, so we need to simplify it. And then we have 4 expressions that are simplified. In this example, we have a little less work to do. I'm going to do what I've done before and use green for my variables, and I'm going to box my variables, negative y and positive 9y. Those can combine to be 9y minus 1y is 8y. And then in blue, I'm going to circle my constants. 10 minus 6 can combine to be a positive 4. And my 8y was positive. So that needs that sign there since we are not combining those terms. They're not like. Now we're going to be looking for 8y's. Well, I see 8y's. I see 8y's. But we're also looking for 4 constants. Those are y's. This is not a constant. And 4 constants. So this is certainly correct. But our other constants, no constants at all, are certainly not correct. Hopefully this has been helpful to you guys. If you are struggling with this topic still, you may find it useful to go back and review PEMDAS, the order of operations, that can be found either in ALEKS if you've not yet completed that topic, or on khanacademy.org. I'd like to do a video with another silly hat, another silly day on that at some point. But for now, have a great day, everybody. Bye-bye!